Now, moving on to part B, we're asked that if we apply a 10 volt potential difference across these 2 points, essentially, we need to find the potential difference across R3 in that resistor. Now, the first thing we want to do is we already condensed the circuit in part A. Now what we want to do is focus on this part here, specifically the equivalent resistance we found for every single resistor combined. The first thing we want to do is sort of find the initial current, the maximum current here. That's the first thing we want to do. So we have the equivalent resistance and we also have the maximum voltage. So to do that, we use Ohm's law. V is equal to IR equivalent. Rearrange for the current, which is voltage over R equivalent, and then plug in the values. So that was 10 volts for the voltage divided by R equivalent, which is 10.58 ohms. I'll plug this into the calculator. And that gives me a value of 0.945 amperes. So that's awesome. So now I'll erase that so that I can have more space, and I'll also decrease the size of my writing. So now I'll use a different color, perhaps something different. The current flowing here before reaching this junction is 0.945 amperes. If I get rid of this, what I am left with is this black colored circuit. We have R1, R4, and R5. Well, actually, no. We have R1, R5, and R1, 1, 2, 3, 4. That's what we really have. The current flowing through this circuit, through R1, R1, 2, 2, 3, 4, and R5, is 0.945 amperes. That's something that has to be understood here. Now what I have to do is I have to pay attention to this resistor, this guy in blue. What I need to specifically do is find the voltage on this blue resistor on R1, 2, 2, 3, 4. I have its resistance, okay? And I have the current flowing through it. So again, I use Ohm's law. V is equal to IR. And I simply plug in the current, which was 0.945 times 1.58 ohms. Now let me plug that into the calculator. That gives me 1.49 volts, rounded to 3 significant figures. So basically, the voltage of the blue resistor is equal to 1.49 volts. I'm writing it up here so I can erase it afterwards. Now what I have to do is I have the voltage on this resistor. Now I'm going to open up this resistor so that I basically get rid of that light blue circuit, which was the condensed form of the circuit, and instead I get R4. Okay, I have opened up the circuit essentially. I'm doing the reverse for now. In part A we were condensing the circuit down, now I'm doing the reverse. I'm opening it up gradually. Now I opened it up, and so we have basically R4 here and this guy in blue, which is R1, 2, 2, 3. Okay, and I have the voltage on R4 from before. Now I have to use basically the resistance of R4 along with that voltage to give me the current in this branch, which is going to be smaller than 0.945 amperes. Why? Because as that current moves this way, it's going to reach a junction and it's going to split into two pieces. So I'm going to do Ohm's law again. V is equal to I R4, and I'll find the current in that branch by rearranging it. So V over R4, the voltage is 1.49 volts divided by R4, which was 2 ohms. So you get a value of 0.747 amperes, rounded to 3 sig figs. So that's the current flowing down here. Once again, I'll erase this. To find the current flowing here, it's easy. You just do the initial current, which was this guy, minus the one we just found, and we get 0.198 amperes, and that's the current flowing this way. Now I have this resistor here, and I also have the current flowing through it. Right now, all we have in the circuit are these 3 resistors. This is one loop in a way, and the other loop is just this blue piece and just this black colored piece here. There's nothing else right now. We're opening it up gradually. So that's the resistance that I've just sort of circled. And I have the current flowing through it. So what can I do? I can find the voltage like I did before for R4. So voltage is equal to I R1, 2, 2, 3. Now, just a quick side note, if this kind of notation does confuse you, you don't have to use it. You can make it easier. You can say like R star or whatever. Just a side note, because it might confuse some of you. What I'm just trying to say is that I've condensed these resistors into one, that's all. So I have the current, I find the voltage, exactly. 0.198 amperes times 7.43 ohms, and then it's going to be 1.47 volts. This is the voltage. of so the voltage of this R1 223 is equal to 1.47 volts. Now what I'll do is I'll open up the circuit again. I'll get rid of this blue piece. Whoops. There we go. So by opening up the circuit, what I've done is this. I have R1 and R223. Now, the voltage I just found for that is kind of useless. Sorry about that. I just didn't realize. So you don't have to find the voltage there. R1 is just this extra piece lying down here. We don't really do much about it. So we have R1, R223, and then we have that current flowing this way. Now, what I'm trying to do again is trying to find the current flowing into this branch. So we're trying to find the voltage of R3. That's the entire point. The potential difference across R3, same thing. I need to find this current. In order to do that, I have the resistance of this guy. That's awesome. Now I need the voltage on this guy. Actually, hold on. So actually the voltage I found before was needed. Again, sorry about that, we had to calculate it. We'll use that voltage and this guy's resistance to find the current here. So forget what I just said about this guy, we do need him. So I would use Ohm's law. I would rearrange it, which is V is equal to IR, so I is equal to V over R. And I'll get 1.47 volts divided by 3.43 ohms. And this is just to find the current that goes down here, which gives me 0.4. That makes no sense because it's higher than the current there, so it makes no sense. It should have been smaller. Give me a second to think about this. I see. So I got a little confused actually. So right now what we have is that entire loop. And right now when we open up the circuit from this resistor, we have the following other loop. We have R1 and we also have R223, the red branch. So right now the current, ignoring the other pieces on the right now what we have is, I'll draw this specific loop again on the side to show you and make it clearer. What we have is R223 and R1 like that, and of course R4 there, and then you have the other circuit and loop here, basically that guy. Ignore him. So this is how this piece actually looks like, and we have that current in orange flowing down like that. So basically I'm going to find the voltage of this guy R223 using that current, using this guy. So actually now So yeah, actually finding that voltage was useless, so you don't do that. Again, sorry for the sudden changes, it's just that these questions do take quite a bit of thinking. So you don't have to find that voltage that I just circled, it's useless. So I'm gonna instead find the voltage of this guy first. So voltage is equal to current times resistance, which in this case is R223, and then the current we have is 0.198 multiplied by 3.43 ohms, and that's going to give us a voltage of 0.70 volts when I round it up. Now this voltage that I just found is not just the voltage of R223, it's the actual voltage of R3. The better way to explain that is to say that when I open up the circuit, so when I get rid of this red resistor and I open it up again, my voltage across R3 was the same as the voltage across that red resistor I just erased. The only thing that changes when you open up the circuit is that, this current is going to change. It's going to become something smaller. And the resistance will also change, because now you're not considering R223, you're only considering R3. So basically, the resistance and the current, they change in order to keep the voltage across R3 the same, which is 0.70 volts, and that applies as well to R4, and I think it was the other resistor in some other color. I think it was blue. That's the same thing for those guys. It's just that the current and the resistance change, hence we keep the same voltage. They both change in order to keep the same voltage. Yeah. So the voltage across R3 is 0.70 volts, and that's correct. That's awesome. Again, I hope this helped you guys. Again, watch these videos on 2x speed. Take care. Have a good day.